Students, I welcome you all in physics classes. Today we are going to start the topic that is electric dipole. First of all, let us know what is an electric dipole. You have studied the molecule of what? HCl. H has positive charge, Cl has negative charge. So when two charges of equal magnitude but opposite in nature are separated by a distance, then the arrangement is called electric dipole. So what is an electric dipole? An electric dipole consists of two charges equal in magnitude but opposite in nature. In case the two charges are separated by infinitely small distance, then it is called ideal dipole. It is called ideal dipole. So what do you mean by ideal dipole? When two charges are separated by infinitely small distance, then the dipole is called, student, infinite dipole. For example, molecule of water, molecule of water, molecule of HCl, these are the examples of electric dipole. Now we come to the term that is called electric dipole moment. What is electric dipole moment? Remember that the product of any one of the charge, the product of magnitude of any one charge with the distance between the two charges is called electric dipole moment. Electric dipole moment is denoted by letter P. So P is called what? Electric dipole moment. So here we have considered two charges plus Q minus Q. They are separated by small distance 12. Then their product, that is Q into 12, is called electric dipole moment. Students, electric dipole moment is a vector quantity. Always remember, electric dipole moment is a vector quantity. Every vector quantity has direction. So question is that, what is the direction of electric dipole moment? Remember that the direction of electric dipole moment is always along the axis of the dipole from positive to negative charge. The direction of electric dipole moment is always from positive to negative charge. Now let us see what is the unit of electric dipole moment. Basically, electric dipole moment is the product of charge with distance. The unit of charge is coulomb, unit of distance is meter. That's why the unit of electric dipole moment is coulomb meter and the dimensions APL. So now you have to remember the dimensions also, because now dimensions are also asked in CV examination. So you should remember that dimension of electric dipole moment is ATL. Students, now we are going to study further a little bit more. If a dipole is placed in an electric field, what will happen? If we place an electric dipole in uniform electric field, what will happen? So we consider an electric dipole consists of charges plus Q and minus Q, separated by distance 12, is placed in a uniform electric field such that axis of the dipole makes angle theta with the direction of electric field. We have studied positive charge always experiences a force in the direction of electric field, and negative charge experiences force opposite to electric field. We have studied E is equal to F upon what? Q. Electric field intensity is defined as force experienced per unit charge. So from this formula, you can write F is equal to what? QE. So the positive charge Q will experience the force QE in the direction of electric field, and minus Q charge will experience the force opposite to electric field. Students, these two forces are equal in magnitude but opposite in direction. Suppose this is a body. One force is acting in this direction and one force is acting in this direction. These two forces are equal but opposite in direction. Then it is called couple. So when two equal and opposite forces act on a body such that they are parallel to each other and their line of action does not pass through the same point, then it is called couple. And the moment of couple is called torque. This couple has a tendency to rotate the body, you can see here, in clockwise direction. So here the dipole is experiencing force equal but opposite on both the charges. The force is equal but opposite. So net force, you will say is 0. Net force on the dipole is 0, but net effect is not 0. What will be the net effect? These two parallel forces will produce couple, and couple has a tendency to rotate the dipole in clockwise direction. Moment of couple is called torque. So we can write torque is equal to force multiplied by what? Lever arm. What is lever arm? Lever arm is the perpendicular distance between the two forces. This is one force, this is another force. So this distance will be called what? Perpendicular distance. That is lever arm. So I can write force QE, lever arm is what? 2L sin theta. This is 2L. This distance is what? 2L. This is your what? 2L. So torque is equal to QE into 2L sin theta, or we can write torque is equal to PE sin theta. So expression for torque comes out to be torque is equal to PE sin theta. Remember, torque is a vector quantity. Since torque is a vector quantity, we can write it in vector form, that is torque vector is equal to P vector cross E vector. Torque is equal to cross product of electric dipole moment and electric field. The direction of torque is given by right hand rule. In class 11, we have studied cross product. The cross product is perpendicular to the plane containing A vector as well as B vector. So students, here also torque will be perpendicular to the plane containing P vector and E vector. So finally we reach to the conclusion that torque acting on dipole is given by torque is equal to P sin theta, or in vector form we can say torque vector is equal to P vector cross E vector.